Okay, so today let's talk about triangles. Okay, so all triangles are either right angled or acute or obtuse. Okay, if the triangle does not contain a right angle means 90 degree, right? You can still find out more about triangles, specifically whether it is acute or obtuse. So we have acute case and obtuse case here, and as you can see, in an acute triangle, all angles are less than 90 degree. So when you have an acute case, all angles are less than 90 degree. If we have an obtuse case, on the other hand, has in obtuse triangle, one angle must be like is greater than 90 degree, and all other angles, the remaining two angles are smaller than 90 degree. Okay, then let's talk about the triangle rule, area of the triangle rule. So we know the area of any triangle can be calculated using the 1/2 times base times height, right? This is the formula of the area of the triangle that we knew so far. However, there are cases that we don't know the height of the triangle. Then we have to use this formula. Okay, this is the formula that is very useful when we have no idea about the height of the triangle. Okay, so you can see that here, if we know the side of the A and B, and then the angle between the two sides, so SAS case, then we can use the area of the triangle formula. Okay, or you can also do, if we know the side C and B, C and A, then and also the angle B, then we can do like A equals 1/2 times A times C times sine B. Okay, or we can also do, if you know the side B and C like this, and the angle A, then we can calculate the area again using 1/2 the two known side, the B and C, and the sine A. Okay, so depends on which side and which angle you know, the variable, because the variable you change, variable is changing. Because the variable is changing, you can change the letters in the formula, right? And also same thing with the cosine rule. Cosine rule works with in any triangles. Okay, it is formula that can be used to calculate the missing side or the missing angle in a triangle. Okay, so cases you can use the cosine rule with the cases that you know are the side, like the SSS case, or you can use it with the case that where you know only two sides and then the angle between it, so SAS case. Okay, so means if you know, for example, if you're trying to find the side C, and if you know the side A and B with the angle between it, you can use this formula to do it. Okay, or it can be rewritten in this format. Okay, both of these equations are the same thing, right? One is derived from the other. Okay, also depends on the which side and which angle you know, the formula changes. So for example, if you know the, like, let's say you're trying to calculate the angle A, okay, and you know the side B and C, and then the course angle between it, then you can do A squared equals to B squared plus C squared minus 2BC cosine A. Okay, or if you know the side B and A, and then the angle between it, then you can do C squared equals A squared plus B squared minus 2AB times cosine. Or if you're trying to calculate the angle B and then know these two sides that has an angle between it, then you can do b squared equals a squared plus c squared minus 2ac times cosine b. So it depends on which side and which angle you know, the formula changes, right? Then the next rule that you need to know is the sine rule. Okay, sine rule is a set of the equation which connects the lengths of the side of any triangle with the sine of the angles of the triangle. In any triangle ABC with the side ABC, units in the lengths and opposite angles A, B, and C respectively. So what this means is, let's say you know the angle A, then the opposite side is called small a. If you know angle B, then the opposite side is called small b. And if you know angle C, then the opposite side is called small c. Okay, and whenever you using this formula, you can either do AB together, so you just have to use two equations, or you can do it this way, or you can use the A and the C together. So whenever you use this formula, you always have to use the 2 out of the 3. Okay, and using this formula, you can either calculate the missing side or the missing angle. Okay, so for example, if you're trying to calculate angle A, okay, then you need to know that it's the corresponding or opposite side, and then the one of the angle and its corresponding side. Okay, then we can do A over sine A equals to C over sine C to calculate it. Or you can put the angles or the tricks signs on the as numerator and the side as a denominator. So it depends on, doesn't matter which equation you use because they are same thing. Okay, and these formulas are all in your formula booklet. Then let's do example 5. So we need to find the x and y in the given figure, right? So the x is here and then the y is here. Okay, we first like to figure it out. The first thing we might want to figure it out is the angles, right? To find the x value, okay, its corresponding angle is this one, right? We are not sure about that angle, but and also same thing, if we want to find the y value, then we need to find this corresponding angle. Okay, so we need to find either one of these angles to find the x value and the remaining y value. Then let's try to find this angle here. Okay, I'm going to call this angle as A. Okay, then its corresponding side is this one. Okay, then we don't know that side, so we cannot do that, right? Then let's talk about the other ones, the other way. So we are trying to find this angle. Okay, we know that this angle is this angle A plus 30 degree plus 118 degree equals to 180, right? Because all the angles inside of triangle add up to 180 degree. Okay, then we want to subtract the A, or we can do 180 minus 30 minus 118 degree, then we can find the A value, right? Then the A value is 32 degree. So we know the A is 32 degree. Then since this part is 90 degree, we know that the remaining angle is same as 90 minus 32 degree, which is same as 58 degree. Then if I redraw this triangle, okay, I know, let's redraw this triangle. Then I know that this is 30 degree, 32 degree, this is x, this is 95 degree, and this is y. Okay, and that means we still don't have enough information to calculate this unknown x and y. So that means we probably have to calculate this length of this side, okay, which is this part here. So let's try to calculate this one, okay. So I'm going to call this side B, okay. Then to calculate the side B, I know its opposite angle, and then I have one more information, which is the 30 degree angle and its corresponding side. Then I can do B over sine 118 degree equals to 22 over sine 30. Then B value is equal to 22 over sine 30 degree times sine 118 degree. Okay, this will give us B value equals to 38.9 meter. Okay, so we know that the yellow line has a length of the 38.9 meter. So 38.9 meter here. Then using this information, we can calculate the remaining. So let's calculate the y value first. So y over sine 32 degree is same as 38.9 over 95 degree. Then the y value is same as 38.9 over sine 95 degree times sine 32 degree. This is equal to 33.1 meter. So we got the y value equals to 33.1 meter. Then we can now calculate the x value, right? We can do exactly the same thing. So x is same x over sine 27 degree. We can calculate that this angle is 27 because 180 minus 95 minus 32 degree, right? So it's 27 degree, and is equals to 38.9 over sine 95 degree. Then we can say that x value is equal to 17.7 meter. Okay, then let's do example 6. We need to find the exact value of the x, giving our answer in the form of the a plus b square root 2, where a and b are possibly a rational number. Q stands for rational number, right? So we know that the x is represent the side that is opposite from the angle 30 degree, and then 2x minus 11 represents the side that is opposite from the angle 45 degree, right? Then we can use the sine rule to solve this question. So I'm going to do a over sine a equals to b over sine b. Okay, then let's say a is x, then sine a is same as sine 30 degree, and b is 2x minus 11, then the angle is sine 45 degree. Then we can rewrite this equation as x times sine 45 equals to 2x minus 11 times sine 30 degree. Okay, sine 45 is same as square root 2 over 2, and sine 30 is same as 1 over 2, right? Then we can say x times square root 2 over 2 is same as 2x minus 11 times 1 over 2. Then we can simplify this, or we can void it, right? Then this will give us the value square root 2 over 2x equals to 2x times 1 over 2 is same as x minus 1 over 11 over 2. Okay, then let's collect the like terms. Then this will say square root 2 over 2x minus x is same as minus 11 over 2. Then this is same as square root 2 over 2 minus 1 x is same as minus 11 over 2. And this is same as square root 2 minus 2 over 2 x equals minus 11 over 2. then we can say the x is same as minus 11 over 2 times 2 times square root 2 minus 2. Then we can simplify this further. Then we can say the x value is same as minus 11 over square root 2 minus 2, which needs to be rewritten as the non-radical form in denominator. So we can do square root 2 plus 2, square root 2 plus 2. Then this is same as minus 11 square root 2 minus 22 over 2 minus 4. Okay, and this is same as, let's write it here. So this is same as minus 11 square root 2 minus 22 over minus 2. Then this can be rewritten as 11 square root 2 over 2 plus 11. So writing in the form of the a plus b square root 2, this is same as 11 plus 11 over 2 times square root 2. And this is your final answer. Okay, then let's do an IB question. So in question number 1, we know that this question is from the specimen paper. So Oli has installed a security lights on the side of his house that are activated by a sensor. This end sensor is located at point C directly above point T. The area covered by sensor is shown by a shaded region enclosed by triangle ABC. The distance A to B is 4.5 and distance from B to C is 6 meters. The angle ACB is given as 15 degrees. The question A, we need to find the angle CAB. So CAB is referring to this part. Okay, so this is your angle CAB. Okay, so for question A, to find the angle CAB, the triangle is very obvious that it is not a right triangle. So we're going to use the sine rule. Okay, the reason why we are using sine rule is because the corresponding side from the angle CAB is given, and also one side value is given with its corresponding angle, right? So we can do side 6 over sine angle CAB is same as side 4.5 over angle sine 15 degree. Okay, then we can say sine C angle AB is same as 6 over 4.5 times sine 15 degree. Then angle CAB is same as sine inverse 6 over 4.5 times sine 15. So the answer is about 20.1874. So the angle is about 20.2 degree. Okay. Then question B, point B on the ground is 5 meters from the point E. So we know that from here to here is about 5 meters. Okay. And at the entrance of to the Oli's house, he is a 1.8 meter tall and then is standing at point D. Okay, so he's standing here. Okay, and his height is about 1.8 meter. Okay, the question says he walks toward to the point B, and then we need to find the distance Oli is from the entrance to his house when he first activates the sensor, right? So from the question, the sensor is located at point C directly above the point D, right? So what we need to do this is we know that the sensor is activated when someone enters the gray area or touches the gray area. So let's figure it out. When Oli moves all the way here, okay, because he's 1.8 meter from the point where he touches the sensor, the gray area, to the ground is 1.8. Okay, so we need to find this point, the length here. Okay, the distance from here to here or here to here, and then subtract from the 5 meter to figure it out the distance all is from the entrance to his house when he first activate the sensor. So in order to do that, since we know the length from this point here to here is 1.8, and we actually know the angle here too. Okay, so we know that this angle is 20.2 degree. Okay, and we have 15 degree here. That means we can find the angle here, right? So angle at the point B is same as 180 minus 15 minus 20.2 degree, or we can say 20.1874. So doing 180 minus the value minus 15 degree will give us about 144.813 degree. Okay, so we know that this is about 144. This angle here is 144. Then we can find this angle as 180 minus 144.813. Then this will give us the angle of 35.1874. Okay, so since we know the angle here and then its opposite angle, we can find this neighboring length, right, which is adjacent, right? Then we can do tangent theta over opposite over adjacent. Then we can say we have an angle tangent 35.1874 and the opposite is 1.8, and we are trying to find adjacent, right? Then the adjacent is same as 1.8 over tangent 35.1874. Then the adjacent value is same as 2.55285. So means we just found value of this side. Okay, so the length of the pink side, or the part of this point B to this point here, let's say this is point star, is 2.55285. Then to find the distance Oli is from the entrance to his house, we simply have to subtract from 5 this value from the 5 meter. Okay, so 5 minus 2.55285, then we get the value of 2.44715. So it's approximately 2.45 meter, and this is the distance that Oli is from the entrance to his house. So this is the final answer. Okay, then let's do question 2. This is the IB question from the example paper. So here we have a farmer owns a triangle field ABC, and the length of the side AB is 85 meters. Side C, another side is AC, and it's 110 meters. The angle between these two sides is 55 degrees. So let's start with the diagram. Okay, so I'm going to say we have a triangular field that looks like this, and let's say this is side A, C, and the B. Then we can say that the side AB is 85 meter and side AC is 110 meter. Okay, and the angle between these two sides is 55 meter. So question A, we need to find the area of the field. So this is non-right triangle. Okay, so I'm just going to use area formula that uses the sine. Okay, the one reason is because I am not sure of the height of this triangle, right? So since you're not sure of the height of the triangle, you have to use the sine area of the triangle rule. Okay, so we can say 1/2, the area is same as 1/2 times the neighboring side, 85 times 110, and then the angle between it, so sine 55 degree. Okay, then this is approximately same as 30,829.5 meter square. So it's approximately 3,830 meter square. Okay, then question B, we need farmer would like to divide the field into two equal parts by constructing a straight fence from point A to a point B on the line BC. Okay, we need to fully justify any assumptions that we are making. So the assumptions that I'm probably going to make is if I choose a point D here, and I'm going to say this is the midpoint. So D is midpoint of the line BC. So if I draw a line from the point D to point A, it divides the triangle equally. Okay, and also I can say that the line from point D to the C, or the point D to the B, so line CD and the line BD are equal to each other, right? Since it is midpoint. This is another conclusion that I can draw from this sentence or statement, right? Then I can say that using the cosine rule, I can calculate the distance of the line BC, right? Then I can say the line BC square is equal to 85 square plus 110 square minus 2 times 85 times 110 times cosine 55 will give me the line BC, right? And then the line BC is same as square root 8,599.12. Then the length of the line BC is same, approximately equals to 92.73, right? Then I can say that since the farmer would like to divide the field into two equal parts by constructing a straight line fence from the A to point D on the line BC. Since the point D is the midpoint of the line BC, then the line CB is equally divided, and then the length of the line CD is equal to length of the BD. And this is the assumption to make to divide the field into the two equal parts.